Hey guys, so before starting this video, I would like to quote a line. Okay, so empty your mind, be formless, shapeless like water. When you put water in a bottle, it becomes the bottle. When you put water in a teapot, it becomes the teapot. And water can flow or it can crush. Be water, my friend. Okay, so these are the words from Bruce Lee. So why I am using this quote here, because whatever is said in this line, it is all true about fluid. Okay, so nearly all materials are either solid or fluid. So the distinction depend on what happens if you apply a force that acts to deform. Okay, for example, bend or twist. Okay, so if you apply a force that acts to deform the material and then remove the force, so we try to understand what happens. Okay, so the deformation that continues after the force is removed is called a flow. Okay, so therefore fluid is simply a material that flows. So fluid mechanics is that branch of science which deals with the behavior of the fluid. Okay, so we discussed in the last class, fluids are liquids or gases, okay, at rest or as well as in motion. So it deals with your static, kinematic and dynamic aspects of fluid. Okay, so now the study of fluid at rest is called your statics. Okay, and the study of fluids in motion where pressure forces are not considered is called fluid kinematics. Okay, so in fluid kinematics we study the motion of the fluid, but we do not consider the pressure forces that causes the motion. Okay, and if the pressure forces are also considered for the fluid in motion, that branch of science is called as fluid dynamics. Okay, so all the forces that are causing the motion. Okay, so if we consider that, so that is termed as fluid dynamics, that we study under fluid dynamics. Okay, so here today we will start with the properties of the fluid. Okay, so properties of the fluid are very much important to understand the behavior of the fluid. Okay, so now we'll take into account one by one the properties of the fluid. So first one is the density or mass density. Okay, so what is density? So it is the ratio of mass of the fluid to its volume. Okay, so it is denoted by symbol this. Okay, this is called rho. So what is the SI unit of your density? So it is kilogram per meter cube. Okay, in CGS it will be gram per centimeter cube. Okay, so mathematically rho is your mass of the fluid. Okay, to the mass of the fluid divided by volume of fluid. So the density of the liquid may be considered as constant, and the density of gases with variation of pressure and temperature. Okay, so gases, the density of gases, it vary with the pressure and temperature changes. Okay, so you can see we can say here the effect of temperature and pressure on the density of liquid is always considered to be constant. Okay, it is very much negligible, so that's why we are taking it as constant, whereas in case of gases the variation is very we can say the variation is very much large. Okay, so if for gases your pressure, if your pressure increases, okay, then density also increases. Okay, it is given by Boyle's law. And if the temperature increases, then density decreases. It is given by Charles' law. Okay, so what is the density of water what we consider in general, it is 1 gram per centimeter cube, okay, and or 1000 kilogram per meter cube, okay. So this is all about the density. So first property of the fluid is density. Now moving to next property is your specific weight, or we call it as weight density also, okay. So it is the ratio of weight of a fluid to its volume, okay. It is denoted by small w. So mathematically we can write it as weight of the fluid to the volume of the fluid, okay. So what is weight? Weight is your mass of fluid multiplied by acceleration due to gravity divided by the volume of the fluid, okay. So here if we write it like this, mass of fluid over volume of fluid multiplication with g. So mass of fluid upon volume of fluid, it is your density, okay. So density multiplied by small g, it is your w, okay. So what is w? W is the specific weight or weight density, okay. So now talking about the unit of specific weight, okay. So this unit, SI unit of specific weight is your Newton per meter cube, okay. And your that W, if we can I will explain you how it is coming. So W is equal to rho into G. So rho is your rho is m over v multiplication with G, okay. So we'll put the units of every term here. So kilogram per meter cube and meter per second square, okay. So we get here Newton per meter cube, okay, because kilogram meter per second square is Newton, that is force, okay. So we are replacing it here it with newtons. So CGS unit is your dyne per centimeter cube, okay. And W for water now, okay. Specific weight or weight density of water is 1000, that is the density of water, multiplied with acceleration due to gravity, that is 9.81. So it is coming out to be 9810 Newton per meter cube. So this is the specific weight or weight density of water, okay. So density of water is 1000 kilogram per meter cube, and a weight density of water is 9810 Newton per meter cube, okay. Now moving to third property. So here it is specific volume, okay. So it is the volume occupied by a unit mass, okay. So specific volume is the volume of the fluid to the mass of the fluid, okay. So we can rewrite it like this: 1 over mass of the fluid divided by volume of the fluid, okay. So specific volume we can write here 1 over rho, or it is the reciprocal of your density, okay. So this specific volume, this property is generally applied to gases, okay. So SI unit of this specific volume is your meter cube per kilogram, or we can say centimeter cube per gram in CGS. So always remember that the units of these terms, these properties are very much important, because whenever we solve the numerical problems, then we need to put the right units in the numerical problem to get the exact solution for the problem, okay. So let us take an example here. Okay, so we have another property that is specific gravity, okay. So what is specific gravity? It is the ratio of your weight density, or the density of a fluid, to the weight density or the density of standard fluid, okay. So standard fluid in case of liquids, it is water, and standard fluid in case of gases, it is air, okay. So symbol is capital S. So mathematically here we can write it as a weight density, or the density of liquid, to the weight density or the density of water. You can take here weight density or density, okay, any one of the term. So if you are taking weight density in numerator, then you need to take the weight density of the standard fluid in the denominator. If you are taking density, then you need to take the density at the denominator. Okay, so for gases, weight density of gas divided by weight density of air. Okay, so here you can see weight density of your liquid is S multiplied by weight density of water. Okay, so S is the specific gravity. So whenever we multiply specific gravity with weight density of the water, okay, so we can get the weight density of any liquid. Okay, so if we want to calculate the density, then we need to multiply it with the density of water. Okay, so you can see here clearly. So now also specific gravity of mercury is 13.6. okay, so the density of mercury we can calculate in the same way, that is specific gravity multiplied by density of water. Here we are talking about density of mercury. If I need to calculate the weight density of the mercury, then I need to multiply it with multiply the whole thing with G. Okay, so here it is coming out to be 13,600 kilogram per meter cube. So this specific gravity is very much important term. Okay, so here I have written some specific gravity of substances at 0 degree Celsius. Okay, so for water it is 1, so blood 1.05, seawater 1.025, or gasoline 0.7, ethyl alcohol 0.79, mercury 13.6, wood 0.3 to 0.9, gold 19.2, and bones 1.72, ice 0.92, air 0.0013. okay, so you can calculate the densities and specific weights of all these substances if you know the specific gravity. Okay, so now let us take a numerical example to illustrate these properties that we have discussed. Okay, so to calculate, so here is the question, here is the numerical problem. So calculate the density and specific weight of 1 liter of petrol of specific gravity 0.7. okay, so the volume which is given to you, the given condition is volume 1 liter. okay, so we'll first of all convert it into SI units, so 10 raised to power minus 3. okay, so meter cube. okay, so we can write it here as 0.001 meter cube. okay, because 1 meter cube is equal to 1000 liters. okay, so you need to know about unit conversions also. okay, so specific gravity given as 0.7 of petrol, we need to first of all calculate the density of the petrol. okay, so we'll use the relation density is equal to specific gravity multiplied by density of water. okay, so specific gravity is given as 0.7 and the density of water is 1000. we know that, so we can calculate the value of density of petrol. So it is coming out to be 700 kilogram per meter cube. Now specific weight of the petrol, so W equal to rho into G. So we will multiply density with acceleration due to gravity 9.81, so it is coming out to be 6867 Newton per meter cube. okay, so it is very much simple to calculate. So now next one is your weight. So weight of the petrol. okay, so we know that specific weight is weight over volume. okay, so volume is given to us. okay, so we'll just put the value here. So small w, capital W over 0.001, so 6867 capital W over 0.001. so capital W, that is the weight of the petrol, is 6867 multiplied by the volume. okay, so it is coming out to be 6.867 newtons. So this is the weight of the petrol. okay, so I hope you are now clear with these properties. okay, we have discussed about density, specific weight, and specific volume, and also the specific gravity. okay, so this is very much important. So we'll discuss about the next property in the next video. Thank you so much for listening. Thank you so much.